Hello everyone, hope you're doing and welcome back to my channel. Today we are at day 6 of the November Daily LeetCode Challenge, and we again have a medium level question in front of us, and it's again related to the arrays, like the normal list arrays, right? So here it is question 3011. Find if array can be sorted. Okay, so if you can see, the input given to us will be a integer array, and in the output will be a boolean. Okay, that is true or false. So you are given a zero indexed array of positive integers called nums. Okay, in one operation you can swap any two adjacent elements if they have the same number of set bits. Okay, you are allowed to do this operation any number of times including zero. Okay, return true if you can sort the array, else return false. Okay, we will again read this question. In one operation, okay, you can swap any two adjacent elements if they have same number of set bits. So the idea here is you can swap two elements only if the number of bits in them are same. Otherwise you cannot be changing the positions, you cannot be swapping them. You are allowed to do this operation any number of times. So for example, if you see here, yeah, this is the array given to us. So first of all, you have to calculate the number of set bits in each one of them. So what is set bit? Basically, I will show you with example also what is set bit. But just for now, note, for example, 8, basically you can write it like this. Okay, so when it comes to 8, okay, 8 can be written like this. Okay, so you have to first of all calculate. See, 8421 rule. Okay, 1000. Okay, 8421. Yeah, 8 can be written in binary form like this. Okay, so that means the number of set bits here is 1. That is the basic idea. Okay, though I am writing here, like this, but in reality we have some many zeros here also. So idea here is, see, each of the zeros have their own power value, right? But the only one which is related to 8 will be set to 1. Okay, this is because 8 is like this. Okay, but if you talk about 7, okay, 7 will be something like this. It will have three ones. Okay, that is the basic idea here. Okay, so see, it's all about binary representation. I'm not going in detail of all these things. Okay, you must be knowing binary representation if you have to solve this question. That I'm not going to teach here, but you can just Google search so that you get a fair knowledge in case you're not having the basic idea about it. Okay, that's the basic understanding. So yeah, you can calculate that. But yeah, in this particular question, I will be using the inbuilt libraries both in Java and Python. I'm going to show the solution for both Java and Python. In both, we'll be using the inbuilt libraries to get the binary representation of it, and we'll be calculating the number of ones in that. That is the basic idea. So now let's come back to the question. In one operation, you can swap any two adjacent elements if they have the same number of set bits. Okay, if you have to swap two elements, they must have same number of set bits. So how to see, first of all, the array is not sorted, right? You have to sort, means you have to do some swappings. To do those swappings, you have to ensure that the element that you are swapping should have the same number of adjacent elements, otherwise you cannot swap them. As simple as that, right? So finally, you have to return true if you can sort the array, otherwise you have to return false. So let us understand this using the first example, right? Here, if you go to the example, you get to know that 8, 8, 4, and 2 are having same number of set bits. That is, each of them are having one set bit. Here, if you calculate 30 and 15, each one they are also having the same number of sub bits. Okay, in this case, it is 3. 30 are okay, it is 4. Fine, it's 4. So 30 and 15 have a 4 bit, 4 bits are set for them. Okay, so these two will form a segment and these two will form a segment. Okay, so what happens here is that, okay, I have made this thing here, like, let me zoom in and show you the tracing for the example one. Okay, so this is the array given to us. We got to know that 8, 4, and 2 have the same number of set bits. Okay, so they form a group, and 30 and 15 have the same number of set bits, they form a group. So what will happen is, inside this group only I can do the swapping. I hope you're understanding. Remember, there are two things here. First of all, the element should be adjacent, only then you can swap. The second thing is, they should have the same number of set bits. So we the idea here is, for example, 8 and 2 can swap. Similarly, 4 and 2 can swap. And let us say 8 comes to the position of 4, then again 8 and 2 will be able to swap. Okay, that is the basic idea. So idea here is, we have to, for example, all the adjacent elements, okay, which are having the same set bit, okay, will form a group actually, and in between that group you can transfer any element to any position. Okay, that is the basic idea here. For example, in this case, 8, 4, and 2, because they are adjacent at the same time, they have the same number of set bits, so I can arrange them in any way that I require. Okay, for example, I will be arranging them like this will, through this they will be actually sorted, right? So 2 will come first, then 4, and then 8. So the idea here is, first of all, how the group should be formed. See, group basically means here that all the elements should be adjacent. Okay, that is the first thing. That should be, that it should be a sub string. Okay, that is the basic idea. It should be sub string of the given input. And the second thing is, all of them should have the same number of set bits. If that is the case, I am very less concerned about them, because I can sort them. Okay, inside that group, every element can be sorted. Okay, like, I can change their positions the way I want. Any element can be taken to any other place inside that group. So in this case, I can sort them. Similarly, when it comes to 30 and 15, remember, they have the same number of set bits and they are adjacent, so I can arrange them like this. Okay, so this is how it will be arranged. Okay, 15, 13. But remember, the elements from this cannot be moved to these positions. Please make this one very clear, because the idea here is for you to swap, okay, for you to swap one element from this particular group to element in this particular group. It is not possible here because they are not having the same number of set bits. Okay, they are not having the same number of set bits, though they are for example, if you see this 2 and this 3 are adjacent to each other, that is fine. Adjacency condition is satisfied, but they are not having the same number of set bits. That is the reason why you cannot swap a element from this particular group to element to this particular group. Okay, that's why I'm saying these two are forming separate groups. So in this question they are using the idea of basically the segments. Okay, so each of these will be forming a segment. That is the basic idea. So if you can apply some more logic, okay, that is, if you try to trace all the examples here, you will get to know that, see, there are I think three examples given. So try to trace all the three. The idea that you will get is that, see here, inside the segment I can sort them. Okay, inside the segment they can be very well sorted. But the idea here is whether, see, but ultimately you have to return the whole, we have to sort the whole array, right? How to ensure that? See, the idea is very simple. The max element of this segment, okay, the max element of this segment should be smaller than every element of this segment. That is the basic idea. So the idea here is, let us say I am in this particular segment, every element of this segment should be greater than the max element of the previous segment. Okay, do you agree with me that this logic will work? Why this logic will work? See, I will sort them the way I need. Okay, that is fine. I will sort it the way I need it. But what is most important, every element then should be greater than greater than the max element of the last segment. Okay, if I can ensure that, for example, after sorting it becomes 8, right? So 8 is the max element of this segment. When I come to this, all the elements here are greater than 8. That means when I sort this segment individually and when I sort this segment individually, together they will become a sorted answer. Okay, together the answer, that is the sub, that array they will form, will be sorted, because this array is sorted in itself. Okay, this array is sorted in itself, this array is sorted in itself, and the max of this is the max of this particular thing, okay, is smaller than all elements of this. That means the it can be pushed in front of it. That's the basic reason. That's why I'm saying, for every segment, every element in that segment should be greater than the max element of the last segment. If we can ensure that, then we can get this answer. If we cannot ensure that, that means the answer is not possible. We have to return false. Okay, we'll see such example. Okay, let me comment this out first. There are such examples here. Okay, let me quickly show you the tracing part of it. Okay, so as I mentioned, this is the first example. Okay, if you see 8, so what I'm showing here, first of all I'm showing the element. Okay, and then I'm printing the number of bits that it has. Okay, number of set bits. So if you see here, 8, 4 and 2 have the number of bits as 1, 30 and 15 have the number of bits at 4. Okay, that is the basic idea. Now just try to see here, what is the max element of this? Okay, max element, this is 8. So every element in this particular segment should be greater than 8. Is it happening here? 15 and 30 are greater than 8, so we are good. This whole answer, this whole thing can be sorted, and that's why we're returning true as the answer. Let's go to the second example now. Okay, so this is a second example. See, this forms a single segment because here number of set bits are same. Okay, this forms a segment. Fine. What is the maximum length of this segment? 2. Okay, right, 2. Now come to this. Okay, this forms a segment. So whether all the elements in this segment are greater than the previous element of the last segment? Yes. The previous, that is the last segment, what is the highest element? 2. 2 is smaller than 3. Okay, that is idea here is all the elements of this particular segment are greater than the previous segment's highest element. So it is done. Now what is the highest element in this particular segment? It is 3. Okay, next, again we are going to the next segment. Okay, whether all elements in this segment are greater than the last segment's, yeah, all the elements in this particular segment are greater than the last segment's highest element. Yes, that is happening because 4 is greater than 3, right? Again we are changing the segment. Okay, whether all the elements in this segment are greater than the highest element of the last segment? Yes, that is happening because 5 is greater than 4. So here multiple segments we had, but yeah, finally the answer is 2 because everything is getting satisfied. But now you will see a different case. Please pay attention here, because this thing will test whether you understood the question or not. Maybe you can pause the video here and try to trace this on your own. But remember one thing, that for every segment, okay, all the elements in that particular segment should be greater than the max element of the last segment. Okay, that is the idea. So if you see here, this forms a segment. Okay, and all this forms a segment. So there are two segments in this particular array. Okay, so it's the first segment. Okay, so what is the max element of this? It is 3, right? Fine. Now let's go to the second segment. Okay, this forms the second segment. All the elements in this segment should be greater than 3. Is it happening? Can you quickly tell me yes or no? That is not happening. Why? See, 16 is greater than 3, I agree. 16 is greater than 3. 8 is greater than 3, I agree. 4 is greater than 3, that is also true. But whether 2 is greater than 3, no, that is not true. So what will happen? You will see 3 will always remain in the starting. It cannot be, swap with any of the elements in this particular segment. Do you agree with me? So 3 will always remain the first element. Okay, if whatever you do, how much ever swapping you do, 3 will not be swapped with anything else, because here the number of bits is not matching with any other element. So 3 will always remain the starting. So the smallest element should be 3, but we see that there is 2 also present. Though 2 should be the first element, but we cannot swap 2 with 3. That is the thing. Because of that reason, this element, this particular array cannot be, swapped. That is the basic idea. So the idea here is, see, all the elements in this should be greater than the max element of the last segment, which is 3. But here 2 is not greater than 3. That's why this thing cannot be swapped. So just try to imagine why it is not possible. See, you cannot swap 2 and 3. Okay, both of them are having different set bits, right? And obviously they're not adjacent, but leave that as the part. They can be this thing is a single segment, right? So you can swap the elements internally in this. So you can make 2 here, okay? Instead of 16, 2 can come here, but still 3 and 2 cannot be swapped because the number of set bits are different in them, okay? But here for swapping you should have the same number of set bits. For that reason the answer is false here. Okay, let's go to the fourth case. So what is, okay, this case I think I've added myself. Okay, this won't be in your question by default. So this is the first segment, this is the second segment. Okay, so what is the max value of this? It is 16. Okay, now comes the second segment. What is, whether all the elements in this particular segment are greater than the max element of the last segment? No, 3 is not greater than 16, so the answer is false here. Okay, that is the basic idea. Now coming to, okay, let us see the constraints also here. Okay, as you can see, it is smaller one. Okay, and yeah, this is fine, but yeah, the length is really smaller. Fine. Now come to the answer. Yeah, so what I'm doing first, see, I've done this prints to just to show you the understanding. Okay, while submitting we'll have to comment it out. Okay, let me do it now itself. We'll have to comment it out before submitting, right? So what I'm taking, number of set bits in the current segment, that is in the current segment elements. Okay, number of set bits in the current segment elements. Okay, so what is that? Initially I will be taking the number of set bits in the first element, that is nums of 0 I will be taking first. Okay, then max element of current segment, again I'm taking nums of 0, max element of last segment. See, because when I'm starting the segment, that is when I have nums of 0, I don't have any segment prior to that. For that reason I will be taking the negative infinite value. Okay, negative infinite float value. Okay, so this will be my max element of the last segment, and max element of the current segment will be nums of 0, right? And n is obviously the number of elements that we have in our input. So I will starting from index 1 till n minus 1. Okay, so what I am doing, first of all, see, yeah, this particular part I just did to show, print and show you that. But yeah, you can start your code with this. Okay, and then you can paste this part. But yeah, because the print will not happen otherwise, so I moved it up. But obviously the first part should be the if statement. Anyway, we'll see that. So first if statement should come. What is that? If nums of I is less than, okay, max element of the last segment. Okay, if nums of I is less than max element of the last segment, you have to return false. Okay, as simple as that. If this condition is not true, that means in the last there is an element. For example, you saw, in this case you saw this particular thing, yeah, you are having a 2, it is not, that is, it is less than the max element of the last segment. Okay, that is why you have to return false in this case. That is the idea. Okay, that is fine. Now what I'm doing, number of set bits is equal to, I'm calculating the number of set bits for the current element. Okay, that is fine. Now there are two cases. This is the first case. Okay, what is that? If the number of set bits match with the number of set bits in the current segment element. Okay, that is, I had already vested element. I have calculated the number of set bits in that, and it is matching that. That is, I am expanding my current segment. Okay, numso is part of the current segment. It will be expanded. Okay, the current segment is getting expanded. So what I have to just ensure, I have to ensure that I am calculating the max element currently. Max element of the current segment is equal to max of the previous, biggest value, and the current nums value. Okay, nums of I, as simple as that. That is when number of set bits match with the number of set bits in the current segment. Okay, if that doesn't match, what that means, that means that the new segment is going to start. Okay, new segment is going to start. For that, what I'm going to do, max segment. Okay, max segment of the current segment. Okay, what you have to do, you have to make it as the max element of the last segment. Okay, this thing will now be made as the max element of the last segment. Okay, and then max element of the current segment, that is this part. Okay, we are going to assign a new value to this, which will be nums of I in this case. For example, in the starting we assigned, okay, this part nums of 0 in the starting. Similarly, when the segment changes, the first, that is the next segment's first element should be assigned to this, as simple as that. Okay, next, number of set bits in the current segment will change. Okay, whatever is the nums of i's number of set bits, that will have to assign it here. Okay, as simple as that. Next, what I'm doing, see, this condition previously did not do the light check. Why? See, when the segment is changing and I'm at the first element of the the new segment, what is happening, this thing max element of the last segment, actually we are going to update it here. Okay, max element of the last segment, but at this point this was not updated. Okay, so since this is the case only for the first element, okay, that's why I will do this check again. If you see, this and this check are exactly same. Okay, I'm doing this check again whenever I'm at the first element of the next segment. That whenever a new segment is starting and I'm at the first element, I have to do this check. Okay, because the max element of the last segment is now updated here. Okay, it is updated here, previously it was not updated, as simple as that. I have to do this check. So whenever these conditions are true, it will be written false. If they doesn't activate, that is, if we don't go to those code, then this whole follow will be done and finally will be written true. Let me quickly run this and show you. As you can see, it is clearing all the test cases. Yeah, as you can see, it's clearing all the test cases, and I have already submitted the solution and got accepted. So the idea here is very simple. You have to break the elements into segments, and you have to just compare that. Like, see, all the segments, you can think of them as a groups. Okay, they are in separate groups. Okay, they're separate groups. What you have to compare, see, the idea is within the segment I can sort the elements. Okay, because I can swap them the way I want. Okay, but we cannot swap elements in between two segments. So for that reason, what you have to ensure, the maximum element of this segment, okay, should be always less than every element of this segment. Okay, because this comes first, right? Remember, this segment comes first. That means after sorting also, this should the elements in this should remain first compared to this. Okay, that is the basic idea, right? So all the elements of this, even including the max element, should be smaller than all the elements of this. That is the very basic idea we am going to follow. Okay, that is the very basic idea. All the elements of this should be shorter than all the elements of this, and like this it will go on. Okay, for every segment, all the elements of that must be greater than all the elements that were previously listed. As simple as that, right? As simple as that. So often that was all for today. This was a good question according to me. Okay, I really liked it. So one more thing here is, see, since they're talking about this swapping, right? And if you see here, the number of if you see the constraints, this number is really small. What other approach you can think of is, it will be the bubble sort. Why? Because even in bubble sort we do this swapping concept, right? We do the swapping concept. So even then you can use that. You can decide whether two swaps are possible or not. If they're not possible, then you will have to return false. Okay, because the number is really small, so bubble sort will be really effective in this case. That is another thing that I wanted to mention you. And yeah, this question was really nice. This was the Python solution for it. I will be again posting the Java solution in some time. So Efan, that was all for today. If you like my efforts, okay, I think this is the day 6 now for the November Daily Code Challenge. If you like my efforts, okay, please do consider subscribing to my channel, because it really gives a lot of motivation to continue further, right? Because see, I, for example, I really worked almost 14 to 15 hours today, and now I'm making this video to upload. Okay, it took really a lot of time. Even during my work, I was analyzing this problem and trying to find what all I can do here. So yeah, it takes really a lot of effort to bring this kind of videos in front of you. Okay, so if you really want to continue in this journey, please do let me know. Okay, that's only possible if you subscribe to my channel. That's really tells me that yeah, I am making some impact in someone else's life, right? So yeah, fun, that was all for today. See you tomorrow. Thanks a lot.